Okay, we're going to be talking about normal distributions today and the empirical rule. Okay, this is the standard. This is the Georgia State Standard. Given a normally distributed population, estimate percentages using the empirical rule. Z-scores and technology. We will be getting to Z-scores on another day. All right, this is just an image that will be in your notes of the symmetrical distribution. And I'm sorry that it's so blurry. I did not realize it would be this blurry when I did it. But as you see, this is the data that is normally distributed. It's a normal little bell-shaped curve, and the mean, the median, and the mode will all be the same number right here. A standard deviation is a measure of how spread out the data are from the mean and is often used when data show a symmetric distribution. We use it a lot when we have that normal bell-shaped curve. All right, and I should have had this earlier, I guess, but this is a picture of when it's not a normal bell-shaped curve. This data is skewed left. That means that my tail is on the left and the majority of my data is on the right. And so this information on the left is skewing my bell to the left, and it's not, it's just not a normal distribution. And this is a photo or an image of a right skewed bell curve where you have a few pieces of data over here, outliers, that are skewing the data, and that's what's going on. These are outliers. Okay, and here is a picture of the bell curve again and the distribution from the mean. So these percentages will be what we will be using. I did find other percentages online, and us teachers agreed that we would use these. So 34% of your data is to the left of the mean. 34% of your data is to the right in one standard deviation. That's what this -1 and 1 means. That's the standard deviation. So one deviation to the left and one deviation to the right, you've got 68% of your data. And then it breaks down. 13.5% falls between two standard deviations of the left, between 1 and 2, 13.5 positive 1 and 2. 2.35 positive 2 and 3, and 0.15 is more than 3 deviations. Same thing over here, only these are negative. So this is what we will be using to calculate with the empirical rule. Okay, here approximately 68% of the data falls within one standard deviation. All I did was add these two up, that's 68. Then the next thing it says is what percent falls between two standard deviations, and you just add up the 68 and then the 27, and that gives you 95% of the data. And then it said approximately how much data falls within 3 standard deviations, and you add up all of these numbers to here, which ends up being 99.7% of the data. Okay. So, and there we are. This problem, this is here for this problem right here. All right. The weights of 50 football players are normally distributed with a mean of 178 pounds and a standard deviation of 8 pounds. What percentage of the players weigh between 178 and 194 pounds? And all you have to do is come over here and see which ones fall between 170 to 194. Right here are those two, and you add these two percentages together, and you get 47.5. All right, this question asks, what is the probability that a player weighs at most 170 pounds? All right, so at most means less than. So we want to find all those players that weigh less than 170 pounds. So again, we go to our curve here, and the ones that weigh less than 170 is these three. So you add these three up, 13.5, 2.35, and 0.15. And you just add them up, and that gives you 16%. What is the probability that a player weighs less than 162 or greater than 194? So less than 162 or greater than 194. We go back to our chart. Less than 162 is these two. Greater than 194 is these two. And you can add all four of them up together if you want to, or you can add these two and then those two and then put them together, which is what I did, but it doesn't matter. And that's what I did right there. All right. Then it says how many players weigh between 170 and 186 pounds. All right, so 170 to 186. We go here, 170 to 186 is 68% of the players. All right, we're going to change that to 0.68 for multiplying. So 68%, to find how many that would be, you multiply your percentage times the total number of players. So 0.68 times 50 is 34 players. Thank you.